the first lesson today is about learning to release code. So this is the part where we're going to make your code pip installable. So this is a really fun lesson, I think, because the process is not hard. It's just kind of annoying, and there are a bunch of steps. But by the end of this, hopefully you can embody this meme. Yeah, I'm glad you like that one. A little rush of dopamine every time someone laughs at a joke. All right, so let's learn how to steal code in order to release code. And just a quick reminder that you all belong here, just like Matt said earlier. This stuff is hard, but it can be learned, and you're learning it. I had a mentor once who said to me that there's a lot I don't know, but there's nothing I can't learn. And so I feel like I took that to heart, and I hope you do. All right, so goals for this lesson. By the end of this lesson, you're going to be able to state the purpose of pyproject.toml, init.py files, license files, and README files. You're going to be able to package a Python project for broad distribution and make your code available on PyPy publicly. So I just want to give you a sneak preview. Let me hide this actually, hold on. I want to give you a sneak preview of what the activities are going to look like for this lesson. So basically, you're just going to make your code pip installable. That's the whole activity. It might take you longer than the amount of time we give during the lesson, so feel free to just get through as much as you can, and then keep working on it with your project groups in the afternoon. So the goals are to create these files that you need for your package, actually package and upload your code to PyPy using Twine, releasing your code on GitHub, and creating a DOI, or digital object identifier, for your package. And this is the thing that's going to make it citable. And then optionally, which is my favorite part, is to add badges to your README file. I'll give you, when we get to that part, I'll show you some badges on the Orbitize page. I like badges a lot. I also really encourage you all to create an initial release today, even or especially if your code is buggy and unfinished. This is pretty low stakes, and it's important to practice releasing the code. So pretty common practice is that if you don't intend the code to be used yet, you can release it as version 0.1. And then once you're actually ready and you're saying, okay, this is a release that I want everybody to start using, you can release it as version 1.0. Huh?
Do you mean tomorrow?
What about?
You said do it today, but they don't have work. They're off this afternoon.
Oh yeah, sorry. By this afternoon, I mean tomorrow afternoon, because you're off this afternoon. Thanks, Jason. All right, so why should we release code? In particular, you all hopefully have your code on GitHub. So at this point, you somebody could theoretically just download your code from GitHub and install it themselves. There are a couple of reasons why we prefer this installing via pip method and hosting things on PyPy. The first is that you get control over setup. So if there's any sort of specific setup things that you want to do when you're installing your code, you can control that. You can do version updating easily. So you can release incremental versions with new features or bug fixes. And that allows your users to keep track of okay, which version am I actually using? And they can easily download and update from one version to another. And then it's also just a nice way for users to install and use packages. All of you at this point have used pip in order to install packages. And I guess saying that installing packages via pip is easy is not true, because we've all run into issues trying to install things with pip. But when it works, it's great. You just write one command and then the code is installed. Okay, so a quick piece of vocab. A package is anything that's installable. So package is package related code together in one place. That's why they're called packages. And this is the dotted naming scheme that Python uses is a really nice way to prevent you from prevent naming conflicts. So if you have two packages that both have modules called utils, for example, this dotted naming scheme allows you to use both of those things at the same time. So modules and packages promote organized programming. So here are some like least information to most information, different like definitions in Python coding. A module is any Python file, effectively, and then a package is a collection of Python files, and critically, the thing that makes a package is that it has this init.py file at the root. This is kind of confusing to people sometimes because a lot of people ask, like, what do I need to put in my init.py file? And there's a lot of things you could put in it, but you don't actually have to put anything. It's just the thing that signals to pip that this is a package. So from least information to most information, we have variables. Then we have functions and classes within one module or within one Python file. Then we have a collection of modules and then a package of the most information. So confusingly, Python treats both packages and modules as type module. And there's an exhaustive like documentation about why that is and more stuff at this link if you're curious. But I say this just because usually when I'm learning about something new in Python, one of the first things I try to do is do this type command just to understand what type of object I'm actually dealing with. And for a while, this really confused me because it was like, what is the difference between these things? But yeah, Python calls them both modules. Okay, so let's look at the top level organization scheme of a package. All of the code that you're going to actually like run in your package should live in one subdirectory. It's pretty common either to call that directory source, src, or the name of the package. So in Orbitize, for example, the root package is called Orbitize, but then we also have a sub directory also called Orbitize, and that's where all the code lives. So we have Orbitize where everything for the package is, Orbitize where all of the like code that actually runs Orbitize is. The init.py at the root is the thing that tells Python that this is a package. And then we've got sub packages in subfolders, and each one of these also has an init.py. So you can define packages and sub packages by just including this init.py at the root of whatever you're defining as the package. And then the way that this would translate to someone using your code is that you would import it like from sound.effects. So this is the sub package that you're importing. Then you import the module echo. So that's one Python file within this package structure. Okay, so we're going to go through all of the files that you'll need in order to release your code. So what we were just talking about is here, this my package. So the top level directory here is my package, and then there's a subdirectory called my package that has all the code files. Then there's all this other stuff at the root, which we'll go through in a minute. So init.py I already talked about a little bit. This is the file that lives in the same directory as your code files. So it's exactly analogous to the init method of a Python class. It's the thing that gets run whenever you instantiate an instance of this class or this module in this case. So it works, it works exactly the same way as the init method. So it'll run through the commands in this file, but you don't actually have to have anything in that. It will just, it's the thing that signifies that this is a package. Yeah, it's just the first thing that gets run. So I want to give you a quick demo of the Orbitize init, so you can understand that a little bit better. Okay, so here's Orbitize. Let me make this a little bigger. Can you all in the back see the text? Okay, awesome. So this is the root level, the Orbitize. There's one directory called Orbitize, which is at the root. And then we've got another directory also called Orbitize. And you can see there are all of these .py files where all of our actual code files live. And we've got this init.py here. So we actually have a bunch of stuff in here. Remember, you don't have to have anything here. And I want to show you what this does. So let's open up a terminal. Let me just first make sure I have this installed correctly. So right now, when we import Orbitize, it's going to define all of these variables. So this is where we define our current version, for example. But anything else you want to do will also get executed anytime you import Orbitize. So as an example, let's add a print statement here. Hi, everyone. I'm going to save it, and then I'll open up IPython, and I'm going to import or solid octo fish stick. There we go. So it's printed my my statement. So this is just code that gets run every time you import your function, your package. Let's go back to the slides. All right. Okay, so we've talked about init.py. Let's next talk about this pyproject.toml file. So a pyproject.toml file lives in the root of your repository, and this is the file that specifies how your code will be built on a new machine. If you have like a sort of, if you don't have anything like fancy in your Python package, this can be very, very simple. This is an entire minimal pyproject.toml script. At the top, it's specifying which backend you're going to use to build your package. And nowadays, there are a lot of these out there. The reasons you might choose one or the other are just like whether, like how they, if they have particular features. So for example, we use setup tools because it's good at building Python packages with C extensions, and a couple of the other ones don't do that. But there are other features that you can look into when you're deciding between these. So this I just copied directly from what Setup Tools recommends. Then we've got descriptions of your project itself. So you can have the name of your project, the version of the project, and then any dependencies here. And there's all sorts of stuff you can do to like automatically update the version, drawing from your init.py file, and like draw your dependencies from the requirements.py file, sorry, requirements.txt file. But yeah, at the minimum, this is sort of all you need. A tip from past code Astros is to not use dashes in your project name. That will work for installing your package, but it'll kind of cause some weird behavior down the line. So even if you like name your Python project like solid dash octo dash fish stick, for example, when you're naming it in here, use underscores. The pyproject.toml framework is actually very new, and I just learned how to use it last night. So you're welcome. So there are several packages in common use. So some other things you might see, it was very common up until recently to use setup.py instead of pyproject.toml. So building using the setup.py rather than pyproject.toml is not deprecated, meaning that like there's still support for that from the setup.py folks. But new projects are being recommended to use pyproject.toml. So you might see this alternate way of setting up packages, especially older packages, which unfortunately Orbitize, I guess, is now classified as. So for a minimal example of a working package that uses pyproject.toml, you can check out my newly released package that I've been working on very hard for a very long time, solid octo fish stick. So I hope you install it and use it in good health. All right. So we've got our definition of our package, the thing that init.py that tells Python that this is a Python package. We talked about the pyproject.toml, which specifies how the code is going to be set up on a new machine. Now let's talk about the license and README files, which are also at the base of the directory, the root directory. So the readme.markdown file is what users will see when they open your package on GitHub. So let's take a look at what this actually looks like in Orbitize. Okay, so in our code, all that this looks like is this. So we've just got, this is written in Markdown, which I think Matt will talk a little bit more about in the documentation lesson. This can be super minimal, or it can be really extensive. We basically chose to have a pretty minimal README file, and effectively the point of the README file is to point to our documentation, which has a lot more information. So you see the first thing that you see is like, go to the documentation if you want more information. And then we've got a lot of badges, because I like badges. So I'll show you what this looks like when you actually look at it on GitHub. All right, so here's our README file. You can see it's displayed very nicely, and all of the badges are there. So that's just the first thing that people see. Oops, I should have not stopped sharing the screen. All right, the license file is some legal mumbo jumbo that copyrights your open source code. And critically, without this, you can't distribute your code. Other people can't use your code. So you should always have a license for your code. If you're wondering about which particular license you could use, there's a really nice link here that sort of walks you through like this flow chart of like, I need to use my code for this reason. What type of license should I choose? All right, so next let's talk about this requirements.txt file. So requirements.txt is a list of Python packages your package needs to run. Those are called dependencies. And it's super simple. It just looks like a list of all the packages you need. All right, so that's pretty much it. Like once you have those things, you can try to install your package locally. So critically, all you really need is this pyproject.toml and init.py files. And here's how you can test your installation. You first cd to the directory containing pyproject.toml, and then type this command, pip install -e dot. You might recognize this because I think this is how we instructed you to install Orbitize. The dot just means like this directory. So look for a pyproject.toml file in this current directory and follow its build instructions to build the code that's in this directory. The -e means that the changes will be reflected on disk. So if you don't include the -e and you make a change to the code later on, that won't, like, if you try to run it, like import and run that code, your change won't be reflected. So the -e says, okay, I don't need to like keep reinstalling it on the disk. Every time I make a change, it'll just automatically do that for you. Yep, question?
So I'm curious, so you mentioned that so the setup.py is no longer recommended. So how can we go to the setup.py if we do not have it?
That is an excellent question. That is a typo. I should have said, yes, it should be pyproject.toml. Thank you. Yeah, so if all goes well after you run this command, it should install your package on your local machine. So you can test this by like cding to any directory on your local machine, and you can just try to import your package. So you can now do this from any directory, not just the directory containing your package.
Hi, Sarah. I had a question.
Yeah.
What's the difference between setup.py and pyproject.toml?
Yeah, so good question. So the question for folks online was, what's the difference between setup.py and pyproject.toml? So the main thing is that setup.py isn't going to be able to use other backends other than setup. I think setup.py also uses distutils, which is sort of, I don't think it's technically deprecated, but so setup.py can only use those two backends, and pyproject.toml is like sort of a superset of that. It can use setup tools as a backend or a couple of other ones. And so the community is moving towards using this pyproject.toml rather than the setup.
Yeah, because I've still seen packages using setup.py.
Yeah, yeah, it's not, and that's what I meant by it's not deprecated. Like, so packages that were built using setup.py probably won't change to using pyproject.toml, but it's being recommended that new packages use pyproject.toml. Yeah, thanks, good question. Yep.
I wonder if this command will also install the package that you set in the requirement.txt, or we still need to?
Yeah, so the question is this going to automatically install the packages in requirements.txt, or do you need to do something different? You do need to do something different. You need to like modify your pyproject.toml file to read your requirements.txt file, and there's instructions about how to do that online. It should be pretty easy to find with Googling, hopefully, but if you run into issues, let me know. I can tell you how to do that. Yeah, great question. All right. Okay, so once you've tested your installation locally and you know that you can install the code correctly on your own machine, the next step is to make your code publicly available. So the way that we're recommending you do this is with PyPy. There's always a lot of confusion about PyPy, pip, and conda, so I wanted to quickly define all of those things. PyPy stands for the Python package index, which is a repository for packages written by the Python community. So PyPy is like a website, a place where Python packages live. Pip, which infuriatingly stands for pip installs packages. I know, it's horrible. I mean, it's great. I love it. It's not horrible. So pip is a package installer tool associated with PyPy. So it's kind of like Git versus GitHub. Like PyPy is the analogous thing of GitHub, and pip is the analogous thing of Git. Pip is a software tool. Conda is a general purpose package management system. So Conda can also install packages, but it's not it's only a subset of packages. So it's not like if you develop a package and want to release it broadly to the community, you're not going to be able to release it on Conda. It's only packages like NumPy and Pandas and things that are sort of like very big, and you might want to like release them with a general purpose Python installation. And there's a link more on pip versus conda if you're curious here. Appreciate the meme. Yay. So this is how you actually install, upload your code to PyPy and make it installable with this command, pip install, whatever your package name is. So Twine is a really nice, useful utility for uploading to PyPy. So what you do is you go to the root of your repository, you're going to install Twine and build. First, you're going to run this command, python -m build, which will build like binary version of your code that can be used for general distribution. And that's going to create this dist directory and put the build files, the binary build files in there. And then you can upload those distribution files using this command, python -m twine upload dist. And that's pretty much it. The other thing to note is that there's also a test PyPy thing that you can use. So rather than uploading to Twine, you can upload to, rather than uploading to PyPy directly, you can upload to test PyPy to sort of make sure everything's working. And if you follow this link, it'll like walk you through how to use test PyPy in addition to PyPy. All right, so I promised earlier in the week that I would give you a crash course on version numbers. And I also want to include a little rant about GitHub releases versus PyPy releases. So every time that we make a significant change to Orbitize, we do a couple of things. We release a new version of the code on GitHub. So that will basically make sure that there is a packaged version of the code that is saved on GitHub with the appropriate version number. And then we'll also release it on PyPy. So that will make this new version pip installable. So best practices are to keep these GitHub and PyPy releases consistent. Right now, the Orbitize GitHub and PyPy releases are not consistent, which is horrible, and I hate it. And the reason why is because I got locked out of my PyPy account, and they won't give me back my access, which is terrible. Yeah. I also got banned from TikTok for multiple community violations.
Wait, what?
I've literally never posted on TikTok.
Why is the violation right there?
Yeah, so I've had really a string of bad luck, and I've been locked out of PyPy for literally months. So actually in the Orbitize doc, I'm sorry, this is terrible, but in the Orbitize docs right now, there's a link where you can go upvote the issue that I raised on PyPy to tell them to reinstate my account. So if you could do that, that would be really cool. Because I'm pretty much directly contradicting my advice to keep the GitHub and PyPy releases consistent. But yeah, another quick like rant about that is that one of the worst bugs that I ever encountered in my life was I was working with a package where I couldn't figure out what was going on because I was looking at the GitHub version of the code and it was behaving totally differently than the version I had pip installed, and I couldn't figure it out, and then finally realized it was because the PyPy and GitHub releases were inconsistent. So the version of the code that I was using was actually different from the version of the code that was on GitHub. So all that to say, good practice to do both of those things at the same time. Another good practice is to maintain a descriptive changelog somewhere in your docs. So this is like for humans, not for computers, and just a high-level description of like what was changed at each major version number. So we can look at what the orbitized changelog looks like. So we've got the version number, the date it was released, and then like one phrase descriptions of all of the things that were changed, and then the person that made the change. And so this goes back a while, so you can like, if there's a particular thing you're, oh, I want to do parallel processing for Ofti, I realize I can't use any versions before 1.5.0. And then a quick crash course on version numbers. The first number in a version number is reserved for major functionality changes. So especially if backwards compatibility is lost, meaning that if somebody is going to run your code, run this new version of the code, like scripts that they had written to use the old version might not work anymore. The second number is for a minor functionality change. So if you add a small new feature, but you're not losing backwards compatibility, that's where I would increment the second version. And then the last one is a bug fix. So you could, for example, have like, you could jump from like 2.5.1 to 2.5.2 or 2.6.0 or 3.0.0. All right, I also want to briefly talk about Zenodo, which is what you can use to make your code citable. There's a nice list of steps you can take to make your code, to set up Zenodo to automatically create a new citation for every release of your code. And this will like track GitHub releases, so you don't have to worry about like manually going in and releasing it. This is really nice because many of you will also like want to publish associated papers with your code, but this is a really nice thing to have in addition / in the meantime. So we go to zenodo.org. I'm gonna log in real quick. Just kidding, I'm not gonna log in. I don't wanna, oh, give me one sec. No, I'm not gonna do it. I think we can just go to the public facing version of the page. Okay, so Zenodo will, it's gonna have the latest version and then all of the things that happen in this latest version. Pretty sure it pulls this from the GitHub release, the description of the GitHub release that you give. And then it also stores all of the old versions along here. So you can also, it's got the binary file, so if you want to like download that version, you can do that from here. It's also something that you could do using GitHub or PyPy. There's a lot of degeneracy in all of these implementations of things. And then another critical thing is you can, it's got the citation down here too. So you can, pick what style you want the citation to be. And then that will automatically cite this version of the code. All right, I also want to briefly talk about publishing software papers. Yep, I made Jason very big. The first thing I want to say is that it's worthwhile to make your code open source, even if you don't plan to publish an associated paper. A really common thing that I hear too is like, oh, my code's really messy, I don't want to make it open source. Like I would love to eventually, but I just can't do it right now. I am of the opinion that it's always worth making your code open source, unless there's something like, if you have unpublished data that you can't publish, or like somebody else's code is in there and they don't consent to their code being open source. Like someone will always figure out a way to make use of your open source code, even if it's like not as well documented or tested as you would like it to be. Yeah, so I personally believe that it's always worth making your code open source. However, publishing a paper talking about the purpose and capabilities of your code is also a good thing to consider doing. Couple of reasons. One, it's just good advertising for your code, and it'll make sure that a bunch more people are aware of your code and think about it when they need to do a particular related task. And it also gives some people something else to cite when they use your code for their own work. I've got a couple examples of software papers in astronomy these are all kind of old at this point. So this is probably not like the sort of most up-to-date recommended way of publishing software papers, but you can check out at least like what we decided to do. I didn't contribute to NC, not me, but advertising my build. And then a sort of more modern option is to consider publishing your code in the Journal of Open Source Software, or JOSS. Some nice advantages of JOSS are that, first of all, there's a completely public review process. So along with your code being public, you'll see the whole history of your code being reviewed by JOSS reviewers. And they'll also review your code in addition to your paper. And that's pretty unique as far as I know. Other journals will review the paper, and maybe the referee will go above and beyond and install your code and try to make sure that it's working and whatever. But in JOSS, it's actually a part of the review process to evaluate your code. And some examples of some JOSS papers is that we've got an in-progress JOSS review for Orbitize v3 that you can check out, and I just linked to the GitHub issue that has the whole review process. And then also a JOSS review that I did over the last year. So you can see sort of, if you're imagining, you're putting yourself in my shoes, something that I submitted to JOSS and something that I reviewed for JOSS. One of the last things I want to talk about is I want to advertise one of our former TAs, Paulina, made an excellent Jupyter notebook in Spanish, taking you through the process of releasing your code. And if you don't speak Spanish, entonces ustedes deberían aprender. Very excited. I've been doing Duolingo for Spanish.
Okay, everyone. I think we'll move on to our next lesson now. I know many of us, we're still working on the pip install stuff. Don't worry, there'll be more time to work on that, especially Thursday afternoon. But today, right now, we're going to switch gears a little bit, and we're going to move into code documentation. And for this, we have a README to follow along with, and also we'll try to do a bit of a type along, like what we did with Git kind of early on. Okay, so first off, where this README lives, open up a web browser and go ahead to the Code Astro GitHub page, and go to the Day 3 folder, and then you can click on Tutorial Doc. And in Tutorial Doc, this is where the README that I'm going to go through lives. So you can, as everyone's navigating to this page, feel free to take a few moments to appreciate our meme about documentation. Yeah. Also, what I'll recommend is that you also have a VS Code window open, where you've opened this Tutorial Doc folder into it, because we'll end up doing some coding in this documentaries, making files. Yeah, so you'll want to have this set up as well. But, okay. This. Okay, great. Okay, so when we start talking about documentation, right, we often get reactions from, especially astronomers, something like this, right? But if we're all true to ourselves, and we all know that documentation really is incredibly important, not just to allow other folks to use your code, but also for you to remember what the code that you wrote 6 months ago does, or in my case, what code I wrote yesterday does. So there's many different types of documentation styles that you can use. One thing you've probably heard of before is called inline documentation. That's where you're coding along, type in your Python file. You write a line of code, and then you just immediately put a comment line describing what that code you just wrote does. I'm not going to talk about inline documentation today. Instead, we're going to focus on what's called Python doc strings. Oh, and for folks in person, don't worry about reading all the little text on this README. This is just kind of, you can always refer to this in the future. There'll be a lot of details there. But I'll be referring to images and steps in this. So, okay. So with doc strings, what is a doc string? That is a block of text that is at the top of your function, and it describes a lot of top-level information about what that function does. There's a lot of different styles of doc strings we can use. In fact, in this README, there's a link here. You can see what styles there are out there. But today we're going to talk about the Google style doc string. And here in this image, we have an example of a Google style doc string. And this broadly has three main parts. Right, so beginning of the file, we start with 3 quotes. That starts the block of text. This first bit just gives a description of the function. You start off at the very top with a very, very short, few words about what that function does. Think about that as the topmost level description. And then underneath that, you can have a block of text that includes more details about the function, what the function does. I mean, in this case, this is a cross-correlation function. This particular function doesn't matter in this example. Okay, so we have the description of the function. The next section we have describes the inputs. And note that in the inputs, it's not just describing what the different input variables are, it also tells you what is the data type of those inputs. This is going to be something that's very valuable to your users when trying to debug or trying to understand the behavior of your code. And finally, the third section describes the code outputs. And once again, it not just gives the description of what the output is, it also tells you what the data type is. Right, so this basic structure is like 80%, maybe 90% of all you need when coding doc strings. This syntax does change slightly when we have specific cases, like if you have optional input variables, if your classes have a slightly different structure. If you're writing exceptions, those have different structures as well. And if you're interested in all those examples, or if that's relevant to your project, you can follow this link in the README here. You'll see more examples than you could ever want of all different cases of how to code it up. But okay, so in addition to providing this crucial information, doc strings are really useful to have and really useful to have standardized because it allows us to automatically build documentation web pages for our functions, right? I mean, think about, you go online, you look at a NumPy function or an AstroPy function. You don't have to open the .py files yourself and scroll through this stuff. There are these nice HTML web pages where everything has been nicely formatted for you. Well, fortunately, you don't have to write those HTML pages yourself if you've used Google style doc strings, or if you've been consistent with some style of doc strings. There are automatic tools out there that will automatically read it and compile those HTML pages for you. And we're going to talk about one of those tools today called Sphinx. Now, Sphinx is something, well, there's more details. You can click the link there later on if you want to. But this is something that was installed automatically in your code Astro environment when you built it during the day 0 setup. So it should already be installed. Okay. So let's dive in and show an example of how to build documentation using Sphinx. We're going to go to the next part of this README. This is the Sphinx Quick Start Guide. And this is where we're going to start toggling between the README and our VS Code window. In the VS Code window, right, again, we opened, this is our tutorial doc folder. And in the terminal window itself, you want to be in the tutorial doc directory. And so in tutorial doc, you'll notice there's a function called correlate.py. We're going to build Sphinx documentation for this correlate.py. Okay, great. So we want to build documentation. How do we begin? Well, what you do, okay, so we're in our code directory, tutorial docs. Let's make a new directory, and we're going to call it docs. Just like that, make dir docs. You can go ahead and cd, right, into docs. And, right, of course, if you do an ls, this is an empty directory. Well, in this empty directory that you just made, we are going to run the Sphinx quick start command. And so what you type in is just Sphinx. Actually, you can see it over here. It's on the README. I didn't even intend for that. That's actually pretty neat. Okay, Sphinx, and then dash, whoops, quick, Sphinx dash quick start. And if you type that in, the quick start utility will begin. Now, there's a few short questions we have to answer first. You'll see the, oh, actually, that's pretty low on the projector. I'm just going to move this up a little bit for now. Yeah, okay. So, right, we're going to get this question. Do you want to separate the source and build directories? Don't worry about that too much right now. This is just like the file structure of the documentation. So you can just go with the default of no. And then after that, you're going to get some more questions. What is the name of the project? I don't know, test docs. I'm not as creative as the Git folks there. And then author name. Okay, great. And put your own name. Project release, right? We just talked a lot about releases with Sarah. We can go ahead and say this is going to be version, I don't know, 0.1. Sure. And then the final question is going to be what language is your documentation going to be? And for the purposes of this example, we'll use English. Okay. And when you answer those questions, the quick start utility will finish. Now, if we do an ls, if we look at this docs directory, which remember was empty before, because we just created it, now you'll notice that it has a bunch of files that Sphinx has created. Okay, great. If you're following along with the README instructions, that was kind of step 2 we just did, and we're just about to jump into step 3. Okay, great. So we can go ahead and look at that directory in VS Code. Now, the next thing we need to do is we need to edit the configuration file of Sphinx, which is stored in this file called conf.py. If you open that, kind of restructure, you have some sort of file, with all sorts of information, right? Oh, here's the project name, here's the copyright, blah, 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 everything we just set up. Okay, so we have to make some edits to this conf.py file in order for Sphinx to compile. The first thing we need to do is we need to tell Sphinx where to look in order to find the .py files that we want to document. We need to make sure our .py files are in the system path. And the way we can do that, you look at step 3 in the README, you see there's a block of text, this import OS, import sys path, insert, blah, blah, blah. Just go ahead and copy that, and you can just paste it at the top of the conf.py file, and then go ahead and uncomment it. Okay. So what this is, if you're, oh, whoops, sorry, I locked my screen. There we go. Okay, great. So this thing sys.path.insert, this is making sure that the that Sphinx knows where to look to find that those .py files. Now, the default values, an os.path.abspath, that's just saying, oh, look in your current directory for the .py files. But remember, we want to do correlate.py. That doesn't live in docs, that lives in the directory above docs. So instead of a dot, we're going to modify this to have 2 dots, which is a relative path that's just saying, okay, look in the directory above this one in order to find the .py file. Okay. Yeah, that's, if you're familiar with setting Python paths in your bash profiles, this is kind of like a similar idea. Cool. Okay, so now our path is set. The next thing, I have to go on down, step 5, we have to make a few other changes to this conf.py file. The first thing we need to specify is what will be the home page of our documentation webpage. And that command is called root doc. We need to say where to go to the root. And we're going to set the root, yes, we're going to set the root doc to be index. Now, what is index? You may note that one of the automatic files that Sphinx created, index.rst. We're going to use that as like the main page with the instructions for our main HTML thing. .rst, by the way, that stands for restructured text. Sphinx builds its HTML pages based on instructions it reads from restructured text. And we're going to talk a little bit more about restructured text as we go along in the demo. Okay, great, perfect. So we've added the root doc. The next thing we have to do, if you scroll down in this conf.py, we need to add just a few extensions. So, right, we have a list here. We go ahead, we're going to add 2 extensions, as you see in this example. The first one we're going to add is called sphinx.x, the extension, I guess, .autodoc. And what this will do is this will give Sphinx the ability to automatically read your documentation and well, document your doc strings. So let's go ahead and put that in. It has to be in quotes. Whoops. Sphinx.ext.autodoc. Just like that. And then let's throw in a comma in there. New line. Now we're going to add the second extension that we need. We hop to the README again. It's sphinx.ext.napoleon. All that does is it tells Sphinx how to read Google style doc strings. So here we go. We'll do the, so let's add it. So again, with the single quotes, sphinx.ext and Napoleon, which I think is spelled, yeah, perfect. I can never spell it right, but that's what the README is for. Okay, we're almost there. We just have to make one last change after that to our conf.py. And that's if you scroll down, you'll see the section that is HTML theme down here. Now, this is purely cosmetic. This is the theme. What does your HTML pages? What are they going to look like? I personally like the Sphinx read the doc theme. So what we'll do under HTML theme, we're just going to say, okay, let's, instead of Alabaster or whatever the default is, let's do Sphinx RTD theme, just like that. Okay, so Sphinx RTD theme, and then go ahead and save conf.py. Okay, awesome. So now we are ready now to build the first version of our documentation. So let's go ahead back into the terminal here, right? We're in this docs directory. At this point, all we have to do is type in the command make space HTML. Go ahead, hit return, and Sphinx does its thing. Now, what has Sphinx done? It has generated HTML files in this directory _build/HTML. So we can go ahead and let's look at that. /build HTML. We look in this directory. Now we see index.html. Well, that's the home page that we had specified. So let's take a look at what that home page looks like in a web browser. Now, if you're on a Mac, well, what you can do in the terminal, you can use just the command open, build, then HTML, index.html, and it'll open up nicely. If you're not on a Mac, don't worry about it. All you have to do is you open a web browser. Well, there might be other shortcuts to do this, but if you open a web browser, you can always just go to File, Open File, and then you can navigate to the directory, and then you just have to open that HTML file manually. So both ways will work. They're exactly the same. Okay. So here we go. This is our docs that we built. It looks really pretty, right? But there's no content quite yet on there. So there's a few more things we have to do in order to document correlate.py. Okay, so let's hop back to our README, and let's hop back to our VS Code. Okay, so remember I said that the way Sphinx works is it builds these HTML files from .rst or .restructured text files. Well, what we need to do is we need to make a .rst file for correlate.py. So let's go ahead and do that. Right in VS Code, we can add a new file. And this is, again, we're in the docs directory. So we're making a new file in docs. And let's call it correlate.rst. And if we do that, right now it's just a blank file. Okay, so this is where some of the magic happens. Once you have this blank file and it's all set to go, if you head over to the README, under step 7, there's a block of text in restructured text format. Let's go ahead, copy that block, and just paste it directly into correlate.py. Okay, well, what is, this looks a little magical. What's going on here? So there's a couple of different parts of this, you'll see. At the very top, you'll see this ... underscore correlation colon. What that is, that's like the label of the web page. You can imagine if you're documenting a lot of .py files, if you wanted to like link, you have a page for one .py file and you want to make a link to the correlation.py HTML file. Well, you can do that by calling it by its name, label name, correlation. This is just like in LaTeX when you do /label, right? That's all that is. That's effectively /label in Sphinx terms. Okay. After that, this doesn't matter. The part underneath doesn't matter too much. This is just text that will show up on your web page. Correlation functions with the equal signs as the underscore, that's represents a title. So it'll render as a title. And then we have kind of some more descriptive things here. And then all the Sphinx commands are in lines 8 and 9, right here. Line 8, ... auto module, colon, whatever. That's telling Sphinx, okay, go ahead, look for a file correlate.py in the path, which we set right at the beginning. And let's go ahead and auto document all the functions that it finds in there. That's what this like members things means. Down here, it's go into correlate.py and document all of the members, all of the functions, classes, so on and so forth. Now in the README at the bottom, there are some more details and more links you can click to learn more about these specific commands. But for the sake of this demo, we're just going to leave it at this and we'll move forward for now. Okay, so let's make sure correlate.rst is saved. Okay, final step. Final step, I promise. This is, if you're following along in the README, this will be step 8. Okay, well, now correlate.py is correlate.rst. It's going to make an HTML file. So let's make sure that's linked to our home page, to the root page, which remember is index.rst. So let's go ahead. We can click index.rst here. There's all sorts of things in this. Let's see, zoom out a little bit. Yeah, the thing at the top. Don't worry about the indices and tables, things at the bottom. What we are going to do is we're going to add our correlate.rst file that we just made under this command that is ... toctree. Toctree stands for table of contents tree. We're just putting this file in the table of contents. Don't worry about max steps or caption right now. Those are just the defaults. There's more in the README on that later if you're interested, but for now, let's ignore them. Okay, but what we will do, right, just like in the README, let's go ahead and add correlate.rst into your table of contents tree. Now, an important note that the spacing here, correlate.rst has to have the same spacing as max depth and caption. Otherwise, this will all fail. Like all the same indentation. I think it's 1, 2, yes, it's 3 spaces. So make sure your spaces line up there. Phew, okay. Now we can build our documentation for real. Now in the terminal, we'll go back. Once again, we're in this docs directory as we've been the whole time. Let's rerun the command make HTML. And now, if all has gone well, which this is a demo, which means that's never guaranteed. Okay, this looks good. Now it's starting to build the new HTML page, right? And hopefully you'll have something like this that is green and looks good. Okay. Now, let's go ahead. Let's go back to the test doc page that we made before and go ahead and refresh the browser. Aha. Now we have a new link correlation functions, the names of the functions in there. Go ahead and follow that link, and you will see very pretty, very beautiful HTML documentation built from the doc strings that you had created. Yeah. Okay, so that's Sphinx in a nutshell. As I said, it saves a ton of time because you will never have to make HTML pages like this by hand. As long as you follow, a doc string style, you can use tools like Sphinx to do this automatically. Okay, great, awesome. Yeah, so that's the end of the demo. Thanks for coding along with me. Before we go into the activity, just a few tips and tricks. Once again, I'm not going to read all of this. You can read it kind of on your own, but things I do want to say. The restructured text files and the Sphinx and the doc strings, they are very sensitive to syntax. If you have a space in the wrong place, if you have a semicolon instead of a colon, that can all cause everything to crash. So if you are running into bugs, just double check your syntax first. A large percent of the time, that's the issue. Also, making these HTML files, we are using this restructured text format. That's something at least I wasn't super familiar with when I started all this. So if you want like a cheat sheet for how to do different sorts of formatting and restructured text, you can follow the links here. Do things like lists and highlights and bolds and, well, yeah, anything you can do. Check out that cheat sheet. Yeah, and if you have some questions about some of the other commands that I kind of threw at you and didn't explain too much, there's a whole section here with some more details. But only if you're interested. That's not strictly necessary for this activity. Okay. Awesome. Now we're ready to go to our activity. So your goal for the next 30 minutes, I think, yeah, is to document at least one of the functions in your package using a doc string. I'd probably recommend using Google style doc strings because that's what we've demoed, but feel free to choose another one if you'd like. But then once you have documented that function, set up Sphinx documentation for it and see if you can build the web page, the documentation. And with that, if you're totally lost, don't worry about it. Right, the place to start with that is go ahead and make a docs directory in your repo, just like we did in step 2. And then you can kind of follow the README down, only instead of the demo values, you can put in your values. Great. And so I think we're gonna just go ahead and wrap up here. Thanks for participating in this activity, and I hope folks are starting to get that documentation to work. Again, if you're running into bugs, don't worry about it. The syntax I know is annoying. There are little things that come up, but yeah, if you're running into problems, feel free to ask your TAs, instructors, post questions, and then we can debug together. So I just wanted to do last couple minutes, just a quick little wrap up, things to think about when doing code documentation. When you're building documentation for your package, it doesn't only have to be, the doc strings copied to everything. You should consider putting things like installation instructions inside your documentation. Quick start guides, tutorials, code examples. Those things are very, very useful for users. I know I really appreciate it when I go to documentation and there's, a nice example that I can copy and use. Also think about, especially if, you're publishing open source software for an academic paper or whatever, put a little note to users how they might properly cite or give credit to your code. Say, cite our Zenodo page or cite this paper. Again, that'll really help users and it'll give you as the developers the credit you deserve. As Sarah mentioned, you also want, a changelog is a really good idea. As you go through new versions of the code and you add more functionality, having a changelog describing those changes is, again, really helpful to your users. And then finally, you can consider having a note how, especially since we're talking about open source software, how might users in the community contribute to your code or raise issues? Do you want them to raise issues on GitHub? You probably do, so it's a good thing to direct them there. If they have a contribution idea, you can say, fork our development directory and then do a pull request once it's done. Just giving the community instructions like that will really help them contribute to your open source code base. And then finally, I know for me, like what I've learned from documentation has been mainly from looking at other like open source code packages and like stealing what they do. So take a look at Orbitize, Radbell, and Spicy is another open source package that yeah, you can check out their documentation. You can go ahead and take the things that you like and, you know, do other things for the things you don't like if you wish.